Module 18.2, Day 1, Sine and Cosine Ratios. Content Standard. Understand that by similarity, side ratio in right triangles are properties of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. Language objective. Explain to a partner how to find the sine and cosine of an angle given a diagram of a right triangle with given angle measure and opposites or adjacent leg and hypotenuse legs. Okay, finding sine and cosine of an angle. Trigonometric ratio. A trigonometric ratio is a ratio of two sides of a right triangle. You have already seen one trigonometric ratio, the tangent. There are two additional trigonometric ratios, the sine and cosine, that involve hypotenuse of a right triangle. A sine of angle A, written sine A, is defined as follows. Sine A is equal to the length of opposite of an angle divided by the length of the hypotenuse. So think of it as sine of angle A is equal to opposite over hypotenuse. Right? Cosine of angle A, written as cosine A, is defined as follows. Cosine of angle A is equal to leg of adjacent of angle A divided by the hypotenuse. So then it's equal to AC over AB. So then cosine of angle A is equal to adjacent over the hypotenuse. Okay. So you can use this definition to calculate trigonometric ratio. So here is a way to think of it as that sine of angle A is equal to opposite over hypotenuse, and cosine of angle A is equal to adjacent over hypotenuse. Right? So if you're looking from angle A, then this is your adjacent, that opposite, and this is your hypotenuse. Right. Okay, so let's go to example 1. Write sine and cosine of each angle as a fraction and as a decimal, round to the nearest hundreds. Right, so here we're observing from, say that we're observing from angle D, and this will be our opposite, adjacent, and hypotenuse. So we say that sine of angle D equal to opposite over hypotenuse, so which gives us 8 over 17, and cosine of angle D equal to adjacent over hypotenuse, so it would be 15 over 17. Right? So if we're observing from angle F, then this will be our opposite. This is adjacent, and this is still our hypotenuse. So we can say that sine of angle F is equal to 15 over 17, and cosine of angle F is equal to 8 over 17. Okay. Notice that these two are equal to each other, and these two are equal to each other. Okay, so for number 4, what do you notice about the sine cosine you find? Oh, my mistake. What do you notice about the sine cosine you found? Do you think this relationship will be true for any pair of acute angle in a right triangle? Okay, so we find that sine of an angle is the same as cosines of 90 degree minus that angle. Right? And this relationship will always be true, okay, because of they are based on the same right triangle. Right? So since this is 90 degree already, so the sum of these two angles must be 90 degree as well. right? Okay, so then let's go to example 5. In a right triangle PQR, so then let's draw our right triangle, right? So we're given that angle Q is 90 degrees, so this is angle Q, and so we can label that's P and that's R. So we're given that from P to R is 5, and from Q to R is 3. Right? Okay, so then we said what are the value of sine P and sine and cosine P? So we need to look for this side first, right? So then we can use the Pythagorean to solve for x. So this is a right angle, so we can say x squared plus 3 squared equal to 5 squared. So then x squared equal to 25 minus 9, which gives us 16. So x equal to square root of 16, which gives us 4. So we know that this is 4. So we're looking for angle P. So we're looking from here. So this is opposite and adjacent and hypotenuse. So sine is opposite over hypotenuse, so which gives us 3 over 5. And cosine of angle P is adjacent over hypotenuse, which gives us 4 over 5. Right. Okay, said use complementary angles. So then the acute angle of a right triangle are complementary. Their trigonometric ratio are related to each other as shown in the following relationship. If angle A and angle B are acute angles in a right triangle, then sine A is equal to sine cosine B, and cosine A is equal to sine B. Therefore, if theta is the measure of an acute angle, then sine theta is equal to 90 degree minus theta, and cosine theta is equal to 90 degree minus theta. Okay. And you can use this relationship to write equivalent expression. Okay, so they said write a trigonometric ratio expression. Given that sine of 38 degrees is approximately 0.616, write the cosine of the complementary angle in terms of sines of 38 degrees, then find the sine of the complementary angle. So we see that sines of 38 degrees is equal to cosines of 90 degrees minus 38 degrees. So then we take 90 minus 38. So this is the same as cosines of 52 degrees, which is equal to 0.616. Okay, let's go on to example B. Given that cosines of 60 degrees is 0.5, find the sines of a complementary angle in terms of cosines of 60 degrees. Then find the sines of the complementary angle. So we see that cosines of 60 degrees equal to sines of 90 degrees minus 60 degrees, which is same as sines of 30 degrees, and is equal to 0.5. Okay, so what can you conclude about sine and cosine of 45 degree? Well, if we were to write sines of 45 degree equal to cosines of 90 degree minus 45 degree, which is the same as cosines of 45 degree. So then we can conclude that sines of 45 degree and cosine 45 degree are equal to each other. Right. So now it's your turn. Given that cosines of 73 degree equal to 0.292, write the sines of a complementary angle. Okay, so work this out. I'll give you 30 seconds and I'll give you the answers. Okay, so now let's do the try it. After verifying that triangle to the right is a right triangle, use a calculator to find the given measures. Give ratio to the nearest hundred and angle to the nearest degree. Number one, use the Pythagorean theorem to confirm that the triangle is a right triangle. Show your work. Right? So then, to show that it's a right triangle, we said 3 squared plus 5.2 squared equal to 6 squared. So if this is true, then it's a right triangle. So then 3 squared is 9 plus 5.2 squared is 27.04 and 6 squared is 36, right? So then we have 3 plus 27.04. So, my mistake, 9 plus 27.04. So this is 36.04 equal to 36. So this is not true, right? But then it's close enough, so then we can say that it might be approximate to a right triangle. Okay, so for number one, we're looking for sine of angle 1. So then sine of angle 1 is opposite over hypotenuse. So then it would give us 5.2 over 6. And so it says 5.2 over 6. We do 2.87. And then we're looking at, so let me erase this part. We're looking at sine of angle 2. So this is angle 2, so that opposite. And this is our hypotenuse. So then it should be 3 over 6 reduced to 1/2. Right. Okay, and then for number 4, we're looking at cosines of angle 1. So then this is angle 1, so cosine is adjacent over hypotenuse, so it would give us 3 over 6 reduced to 1/2. Okay, and then looking at cosine of angle 2, so then this is adjacent over hypotenuse, so then it would be 5.2 over 6. And so 5.2 divided by 6 give us 0.87. Right? Okay, and then so for number 6, show how to find the measurement angle 1 using the inverse sine of angle 1. Well, let's go back to number 2. So we know that sine of angle 1 is equal to 0.87. So then the measurement of angle 1 equal to sine inverse 0.87. And from there, just use your calculator. Make sure that you use the shift or the second key on your calculator. So then angle 1, we want to round it to the nearest degree, so then it's approximately 60 degrees. Right? Well, since it's a right triangle, if we know that angle 1 is 60 degree, so angle 2 must be 30 degree. Okay, so let's see if it works. Right? So we say that the measurement of angle 2 equal to sine inverse of 1/2. Okay, so this is based on number 3. Right? So then use your calculator. So this comes out to be 30 degrees. So it's the same as that. Right, okay, so now to find the measurement. Okay, so similarly, make sure that on your calculator there's a degree sign. Okay, use the calculator and trigonometric ratio to find each length round to the nearest hundredths. So here we're asking to find the length from B to D. So if we're looking from this angle, we have the opposite and hypotenuse. So since we have opposite and hypotenuse, we need to use sine. So then this is sine of 62 degree is equal to opposite over hypotenuse. Right, so that means that we can use the cross product. So BD is equal to 11 over sine of 62 degree, and then use your calculator. 11 divided by sine of 62 degrees, so this gives us 12.4583. Okay, and round to the nearest hundreds. Right, so then it would be 12.46. And for number 9, we're looking at this angle, and we're solving for P to Q, so we have adjacent and hypotenuse. So then we have to use cosine. So you do cosines of 38 degree equal to adjacent over hypotenuse. So using your cross product, so then PQ equal to 25 over cosines of 38 degree, and then use your calculator. 25 divided by cosines of 38. So this gives us 31.73. All right. Okay, let's go on to number 10. So we're looking for ST. So then we're looking from this angle, so adjacent over hypotenuse. So similar to number 9, we need to use cosine. You do cosines of 27 degree equal to adjacent over hypotenuse. So then this gives us 5 over cosines of 27 degree. So then it would be 5.61. Okay, so that's the end of our 18.2 Day 1 notes. Your assignment is number 1 through 8 in your textbook. And you have a new XRW on 18.2. You also need to copy down 18.2 Day 2 notes.